Today is section 2 of chapter 8, which is adding and subtracting rational expressions. So yesterday we multiplied and divided, which is probably the easiest of the four. Now adding and subtracting are going to be a little more difficult. So just a little fair warning there. So most of what's happening here is we're going to create, if you remember back to adding and subtracting fractions, is getting like terms in the denominator. So that's what we're going to have to do first. So in order to add and subtract fractions, you must have a common denominator. We must find the least common denominator, or the LCD, by finding the least common multiple of the denominators. So in order for us to do that, we're going to take a look at what our denominator is. Again, factor first, and then take a look at how to move on from there. So we're going to start by just looking at these three terms and figuring out what's the least common multiple. So I'm just going to kind of separate these out a little bit. So we have 18 r squared s to the fifth. We have 24 r cubed s t squared. And then we have 15 s cubed t. Remember, the least common multiple means all of these numbers go into that number. So the first thing we want to do is discover what's the least common multiple between 18, 24, and 15. Well, if I break each of these down, this one is 3 times 6, which is 2 times 3. So that's 2 times 3 squared. This one breaks down into 12 times 2, which is 4 times 3, which is 2 times 2. So then we have 2 cubed times 3. And then 15 is just 5 times 3. So that's how we break this down. So you break them down into their prime factorizations. And now we're going to take a look at each of these numbers. So we want to make sure we include all of the numbers at least once. So I have a 2 and a 2 cubed. You want to use the number that has the biggest exponent. So I'm going to use 2 cubed. So we're not using this 2. So for my LCM, I'm using 2 cubed times. We have 3 squared, 3, and 3. So I'm going to use 3 squared, not the 3's. So 2 cubed times 3 squared times. Then I also have this 5. So I'm going to include a 5. Then we also have to include the variables. We have to have every variable present. So we have an r, an s, and a t. So we have r, s, t. But again, you want to use the highest exponent. We have r squared and r cubed. So we're going to use r cubed. Then we have s to the fifth, s, and s to the third. So we're going to use s to the fifth. And then we have t squared and t. So we're going to use t squared. So if I multiply this out, we end up with 8 times 9 times 5. R cubed, s to the fifth, t squared. So we end up with 40 times 9 is going to give us 360. R cubed, s to the fifth, t squared. Now ours will not typically be that lengthy. When they look for just this, they will be. But when we're looking for fractions, we're not usually going to have that complex of denominators. This is just to kind of give you an idea of what we're doing and looking for the least common multiple. So remember, the least common multiple means all three of those things have to go in it. So you're looking at the prime factorization and picking the highest exponent value. Okay, so now they want us to find the LCM of polynomials. So this is what our adding and subtracting is going to be more like, because we're going to have polynomials or monomials or whatever in the numerators and denominators. So let's take a look at what this looks like. Again, the same thing as yesterday applies. The first thing we want to do is to factor every one of these polynomials. So as many fractions as we have, factor the denominators. So I'm going to start by factoring p cubed plus 5p squared plus 6p. We can start by pulling out the GCF, the greatest common factor, and we're left with p squared plus 5p plus 6. How does that factor? It's going to be p plus 3 times p plus 2. So that's our factorization. Now let's factor p squared plus 6p plus 9. So then we have p plus 3 times p plus 3. Same thing as what we did before. We're going to look for what do I have and how many of them do I have. So this can be rewritten as p plus 3 squared. When we have the same thing multiple times, you want to follow the same rule. Look for the highest exponent. So I'm going to use first a p, because I have one of those. We're also going to use the p plus 2. And then we're going to use p plus 3, but I'm going to square it because you want to take the highest exponent. I'm not going to use this one. I'm going to use the squared version of it. And that's our least common multiple. Now I'm not going to require right now that you multiply through and look at all of that. For now, you can leave it just like that. So let's take a look now at how we would add and subtract rational fractions. So let's take what we've just done and apply it to these fractions. So we want to start by looking at our two denominators. I'm going to factor them. So we have 7x over something plus y over something else. Over here we have 5 times 3 y squared. Over here we have 6 times 3, which is 2 times 3, so we have 2 times 3 squared xy. So again, let's look for what do we have in common already. They both already have 1 3, but we need 2. They both already have 1 y, but we need 2. So what's going to happen here, and this is where it gets a little tricky. Whatever this one has that this one doesn't, we multiply this one by. So notice over here, we're missing a y and we're missing a 5. So I'm going to multiply this one by 5y over 5y. I'll do that again. Over on this side, we're missing the 5 and we're missing one of our y's. So I did 5y over 5y. Now what's missing on this side? We're missing one of our 3's and an x. So I'm going to multiply by 3x over 3x. And that's going to get me the same denominator. Now, could you multiply by the full denominator and the full denominator? Yes, you could, but that's going to give you much, much bigger denominators than you need. So by breaking it down and factoring it, we can look at, okay, what do I need and what do I have? So 3x times 7x is 21x squared plus, over here we have 5y times y is 5y squared all over these things combined. And really you just need to do it once. Excuse me, we were also missing a 2. I forgot about that. So this should have been 6, because we're missing a 2 and a 3. So that would have been 6x and 6x, which changes this to 42x squared. So then we have all of this combined. So we have 6 times 15, which gives us 90. X, y squared. Now we can't reduce because we're adding here, so nothing can be simplified because we only took the minimal pieces. If you multiply this whole denominator by this whole denominator, you're going to have to simplify and you'll get this answer anyway. So if you put some of the work in here by factoring it and figuring out what you're only missing, that's going to help you later on so you will not have to simplify. Let's do it again with subtraction. So again, we have 9b and 7ab squared. The only thing we can factor here is the 9. I can make that 3 squared b minus 1 over 7ab squared. What am I missing? On this side, I'm missing 3 squared, and that's it. We're missing the 9. Because we already have an a and we already have b squared, which is more than they have. What am I missing on this side? Over here, we're missing a 7, an a, and a b. So we have to multiply by 7ab. So let's multiply. 7ab times 8a is 56a squared b. 3 squared times 1 minus 9 all over the whole thing. So 9 times 7 is going to give us 63 a b squared. Again, no simplification because we're subtracting here. Let's take a look at what happens when we have polynomials on both the top and the bottom. So on this one, again, the first thing you want to do is try to factor the denominators as much as possible, because that's going to tell you what you have and what you don't. So instead of having monomials, now we have polynomials. So we're going to have to look for first the GCF, and then we're going to have to factor it. So what's my GCF between 4w and 16? It's 4. So I'm going to have 4 times w minus 4. And the top is just going to say w plus 12. Minus. Over here when I factor the denominator, we factor out a 2, and I have w minus 4. Well, that's really convenient, because now they both already have w minus 4, and I just have to multiply, actually this one, if I rewrite the 4 as 2 squared, it already has a 2. I just have to multiply this side by 2. This one already has everything. This one was just missing a 2. So over at this side we have w plus 12 minus the quantity 2 times w, which is 2w, plus 8. And make sure you put this in parentheses so that negative goes to the whole thing. And then all of this will be divided by 2 squared w minus 4. So here we have w plus 12 minus 2w minus 8 all over 4w minus 4, which is going to reduce to negative w plus 4 all over 4 times w minus 4. Now notice, we're really close to having these the same, because if I rewrite this, that top is 4 minus w, and on the denominator we have w minus 4. So remember, if I make that negative, if I multiply that by negative 1, I'll put it here. If I multiply that by negative 1, now that becomes 4 minus w. And now I can reduce by canceling those and just be left with 1 over a negative 4. So that whole problem ended up reducing to a negative 1/4. And again, that's just a lot of fraction work with combining like terms, a lot of algebra in there with simplification. There's a lot of little things in there that we've been working on, we've been putting together, that are all kind of coming around into these problems. Okay, what happens when we have complex fractions? So we talked about complex fractions yesterday. Remember, the complex fraction is just a fraction within a fraction. We're going to do similar things we did yesterday. The only thing is, I'm going to tear the fraction apart before I put it back together again. So what I'm going to do is we're going to work with just the top, and then just the bottom, and then simplify. So let's work with just the top. So if I have 1 over x minus 1 over y. Well, how do I make these have like denominators? I multiply this by x over x. And I multiply this side by y over y. So now this becomes y minus x all over x times y. That's my numerator. Let's work with the denominator. We have 1 plus 1 over x. 1 is a really good thing, because you can make this whatever you want over itself. So all I'm going to do is change that into x over x. That's 1. And that will become x plus 1 over x. That's my denominator. So now when we have y minus x all over xy, we're dividing that by x plus 1 over x. Remember, rewrite this as division from yesterday. We do y minus x all over xy times the reciprocal x over x plus 1. And now we can reduce. The x's will cancel, and that's what we're left with. So now we're left with y minus x all over x plus 1. So treat those as two separate problems and put it together. At the end, remember, complex fractions, treat them as a division problem. You take the top one times the reciprocal of the bottom one. Okay, I want you guys to take a few minutes and figure these ones out on your own. So please pause the video at this moment and figure these out, and then come back and I'll have worked them out and you can check your work. Your homework for tonight is page 454, numbers 18 through 32, just the even ones. When I say tonight, I mean tomorrow in class.